Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 17. Let's get started. All right, we're going to write these ratios as rates, and I'm going to find the unit rates that are associated with each of these. So let's start with Part A. The ratio of miles to the number of hours is 434 to 7. So I'm going to write that in fraction form, 434. And the first thing I'm talking about is miles, so this is miles on the top, over 7, and the second thing we're talking about is hours. Remember, order is everything in a ratio, and then we're going to find out what 434 sevenths is if I actually do the division. So 434 divided by 7 equals 62, so this is 62 miles for every 1 hour, and that is the unit rate. Okay, and this is just unit rates are a way to make the race fare. We did a lot of this before where we made the number of hours the same by scaling up, and now we're just scaling down. We're moving it down to 1 hour. How many miles in 1 hour? Okay, and for Part B, the ratio of the number of laps to the number of minutes is 5 to 4. 5 is the number of laps, and 4 is the number of minutes. And then we just do what the fraction says, 5 divided by 4. And when we do 5 divided by 4, we get 1.25. And this is laps every 1 minute. Okay, so there is our unit rate. Next, Dave can clean pools at a constant rate of 3/5 pools per hour. What is the ratio of the number of pools to the number of hours? Remember, order is everything. The first number corresponds to the first unit. So that's 3 pools every 5 hours. Okay, so we've just got the order. 3 is the first number, so that's pools. 5 is the second number, so that's hours. So 3 pools in 5 hours. How many pools can Dave clean in 10 hours? Well, I'm just going to make a ratio. I'm going to use my ratio, 3/5. Remember, this is pools and this is hours. And I'm going to create an equivalent ratio that also compares pools to hours. Only this time I want my number of hours to be 10. So I'm going to put a 10 here. And now I can see that if I just multiply each of these by 2, so I'm multiplying by the number 2 over 2, then I get 5 times 2 is 10, so I get my denominator the way I like, and then 3 times 2 would be 6. And that is our answer. How many pools can Dave clean in 10 hours? 6 pools. How many can Dave clean in, how long does it take Dave to clean 15 pools? Well, let's start with our original ratio. Again, 3 to 5. Remember, that's pools to hours. And we're going to make an equivalent ratio that also compares pools to hours. Remember, we have to say consistent and corresponding. 3 to 5 is my pools to hours. And now I know that I want him to clean 15 pools. Well, 15 would go on top this time because that's the pools number. And then we can decide what we have to multiply by to make 3 into 15. 3 times 5 is 15. So 5 times 5 is my number of hours, and that's 25. So how long does it take Dave to clean 15 pools? 25 hours. Next, Emmeline can type at a constant rate of 1/4 pages per minute. What's the ratio of the number of pages to the number of minutes? Okay, order is everything. There's 1, that's pages. So it's 1 page for every, and then let me get a different color here so I can illustrate this. The next number is a 4, so that goes on the bottom, and that's talking about minutes. So it's 1 page every 4 minutes. Order is everything. Emmeline has to type a 5-page article, but only has 18 minutes until she reaches the deadline. Does Emmeline have enough time to type the article? Well, let's find out. Let's use the ratio that we came up with. That's 1 page every 4 minutes, pages to minutes. And I've got a choice here. I can make the number of pages 5. Let's do that first. So still I'm going to compare pages to minutes, and I'm going to make the number of pages a 5. Now I can see that if I multiply the top by 5, 1 times 5 is 5, so 4 times 5 is my number of minutes. So 20 minutes. But she only has 18 minutes until she reaches the deadline. Does she have enough time? No. She needs 20 minutes to complete it. She only has 18 minutes until the deadline. Part C, Emmeline has to type a 7-page article. How much time will it take her? Well, we're going to use our original ratio again, 1/4. That's pages to minutes. And this time I want my number of pages to be 7. So I'm going to put a 7 on the pages side. And then I'm going to find my constant. I know I can multiply by 7. 1 times 7 is 7. So 4 times 7 gives me 28. 7-page article would take 28 minutes. Number 5, Xavier can swim at a constant speed of 5/3 meters per second. What is the ratio of the number of meters to the number of seconds? Okay, order again. 5 is the number of meters, so I'm going to put 5 meters over 3 is my second number, so that's a 3, and we're talking about seconds. So 5 meters every 3 seconds. That's our ratio. All right, Xavier is trying to qualify for the national swim meet. To qualify, he must complete a 100-meter race in 55 seconds. Will Xavier be able to qualify? Well, let's use our original ratio, 5 meters every 3 seconds. And we're going to create an equivalent ratio that also compares meters to seconds. And I know that he's got to do a 100-meter race, so I'm going to put 100 on the meters side. Now I look for my constant. 5 times something is 100. Well, 5 times 20 is 100. So 3 times 20 will be my number of seconds. 3 times 20 is 60. Xavier can swim 100 meters in 60 seconds. Will he qualify? No, because he has to have it done in 55 seconds. Part C, Xavier is also attempting to qualify for the same meet in the 200-meter event. To qualify, Xavier would have to complete the race in 130 seconds. Will Xavier be able to qualify in this race? Well, let's use our original again, 5 meters over 3 seconds. Remember, this is meters to seconds. We're going to create an equivalent ratio that also compares meters to seconds. And let's use this 200-meter event. So the 200 goes in the meters slot. And then 5 times something is 200. 5 times 40. 5 times 40 is 200. So 3 times 40 will be my number of seconds. That's 120. So a 200-meter race will take 120 seconds. He has to complete it in 130 seconds. So yes, he would qualify for the 200-meter event. Okay, last one. The corner store sells apples at a rate of $1.25 per apple. What is the ratio of the number of dollars to the number of apples? Order, $1.25, that's dollars. So I'm going to put dollars, 1.25. Over, well, we don't have a number, but we do have apples, so that's 1 apple. So it's $1.25 for every 1 apple. That's our unit rate. Akia is only able to spend $10 on apples. How many apples can she buy? Well, I'm going to use my original rate, $1.25 per apple. So this is 1.25 for every 1 apple. I'm going to put that over here. And that's going to be equal to the same comparison, dollars to apples. And I know that Akia is only able to spend $10, so I'm going to put 10 there. Now, $1.25 times something is 10. If you don't know that fact, then divide, work backwards. Take this 10, put it in your calculator, divide it by the $1.25. 10 divided by 1.25 is equal to 8. So 8 is my constant. 1.25 times 8 is 10. So 1 times 8 is the number of apples I can buy. So $10 will get Akia 8 apples. Christian has $6 in his wallet and wants to spend it on apples. How many apples can Christian buy? Well, we're going to use our same rate. It's $1.25 for every 1 apple. And we're going to create an equivalent ratio that also compares dollars to apples. And I know Christian has $6, so that's going to go in the dollar section. And again, if I don't know $1.25 times something equals 6, if I don't know that, then I'm going to work backwards. 6 divided by 1.25 is my constant. So my constant is, let me get a different color. My constant is 4.8. If I multiply 1.25 times 4.8, I'll get $6. So that means 1 times 4.8 is the number of apples I could buy with $6. Well, I can't buy 8/10 of an apple, and 5 apples would be too expensive. So my answer here is 4 apples. Christian can buy 4 apples. All right, that's lesson 17. Hope that helps. See you again next time.